Good afternoon. I am Dr. Rekha Ovhal, Assistant Professor, Department of Chemistry, Walchand College of Arts and Science, Solapur. My today's topic is the solid state. Introduction. The chemical substances exist in three different states, namely solid, liquid, and gases. The constituent particles of matter, atoms, or molecules show different interactions with each other in these three states. Solid state is nothing but the study of crystals. The units of solids, atoms, ions, and molecules are firmly bound together. There are two types of solids, amorphous solids and crystalline solids. Coming to amorphous solids, these solids have no definite geometrical shape and also no regular arrangement of individual units. The crystalline solids, these solids exhibit a regularity in arrangement of structural units and have sharp melting point and a particular geometrical shape. Crystallography, it is a branch of science which deals with the study of geometry, properties and structure of crystals. Study of crystals includes geometrical crystallography, the examination of external form and the elucidation of internal structure. Geometrical crystallography deals with the study of outward spatial arrangement of crystal planes and the geometric shapes of the crystals. It includes the terms like space lattice, lattice sides, lattice planes and unit cell. We'll see these one by one. Space lattice, it is also called as crystal lattice, a systematic and symmetrical three-dimensional arrangement or network of points, that is atoms, ions and molecules arranged in a regular manner, is called space lattice. Lattice sides or lattice points, these are the positions occupied by the particles in the space lattice. The lattices are bound by surfaces and are generally planar, and these are called as faces of the crystal. The angle between two intersecting faces is called interfacial angle. Lattice planes. The structural units or points can be visualized as arranged in a number of parallel and equidistant planes. The crystal of NaCl consists of a perfectly regular arrangement of Na plus and Cl minus ions, and the space lattice of NaCl is made up of the interlocking of Na plus and Cl minus lattices. Then unit cell, it is the smallest unit into which the crystal can be imagined as subdivided without losing its essential properties. The unit cell is the simple unit of it. The space lattice, which when extended in three dimensions reproduces entire crystal lattice. Here I have shown the unit cell of NaCl crystal, which I have taken from the given link. Then fundamental laws of crystallography. It includes the law of constancy of interfacial angles, the law of rational indices, the law of symmetry. We'll see these one by one. The law of constancy of interfacial angles. The shape and size of crystal may vary with the conditions under which crystallization occurs, but the angles between the faces are always constant. Then the law of rational indices. The law states that it is possible to select the three coordinate axes of unit distances in such a way that the ratio between the intercepts for different phases of crystal on these axes can always be expressed by rational numbers. Then the law of crystal symmetry. All crystals of the same substance possess the same element of symmetry. Symmetry is the most important property of the crystals and is related to the crystal phases. Crystals have several types of symmetry. The simplest three elements of symmetry are as follows: the plane of symmetry, the axis of symmetry, and center of symmetry. A crystal can have one or more planes and axis of symmetry, but never more than one center of symmetry. Now, the Weiss indices and Miller indices. The position of plane in space can be represented by three coordinate axes x, y, and z. It is possible to determine the phase or plane of a crystal by noting its points of intersections with three axes. These intercepts of the plane on three coordinate axes are nothing but the Weiss indices. Weiss indices are not always simple integral whole numbers but may have fractional values as well as infinity. In crystallography, the planes are generally represented by Miller indices. These are nothing but the reciprocal of Weiss indices or the reciprocal of the intercepts made by the plane on three coordinate axes and are expressed as the smallest whole numbers obtained by multiplying throughout by the smallest number. Miller indices are also called as HKL values of the plane. Cubic lattice and types of cubic lattices. The cubic lattice is the simplest and represent the greater symmetry. The cubic system has three types of space or crystal lattices. 1. Simple cubic lattice. The unit cell of simple cubic lattice consists of 8 points situated at the 8 corners of a cube. Second, face-centered cubic lattice. This unit cell contains 14 points. 1 point is situated at the center of each face and one at each corner of the cube. Third cubic lattice is body-centered cubic lattice. The unit cell of body-centered cubic lattice consists of 9 points. 1 point is situated at the center of a cube and 8 at corners of a cube. And that is all about solid state today. Thank you.